So okay, but I'm gonna specifically teach you about the application of Newton's second law of motions. So as you can see, there's a person that is pushing the packs. So the second law of motion states that the rate of change of momentum of an object is directly proportional to the force applied, or for an object with constant mass, then the net force on an object is equal to the mass of that object multiplied by the acceleration. Just simply, or hence the formula, force is equals mass multiplied by acceleration. So we're gonna use that law to solve real life problems. So as you can see, there is an belt conveyor, and let's play it. How much force is the conveyor have to apply for that three boxes to go from here and to very top? So we're gonna use Newton's law of motion. But before that, let us first draw a free body diagram. So that is the belt conveyor, the three boxes, the normal force, friction, of course, force applied, as just I said earlier, the weight, of course, you must not forget that, and that. You can see here that the weight is distributed to the x-axis and the y-axis, because this is because of the elevated or inclined plane. But if the plane or is flat, the weight won't be distributed. So the normal force is just a force perpendicular to its surface. That so that is every force that is related to this problem. So next we must find this, the force applied, and the friction, and these two, and the normal force. What we all have now is just this distance, the angle of elevation, and the weight, which we will know later. So we must first know the weight. The weight is clearly just mass times acceleration. This acceleration is due to gravity, or 9.81 meters per second square. So you see the answer, but I will explain it to you. 5 kilograms is the mass of each boxes. So in here we have 3. So multiply that by 3 and times the acceleration, and we have 147.15 kilograms per meters per second square. Or this is just Newton, the force. So next, we will solve the normal force, or Wy. As you can see, we have the equation here, cos theta. It is cos theta because it is the adjacent of a right triangle. Ka, so katoa, ka. So that is it. And we have, okay, let me explain. Weight cosine theta is equals to 147.15 cos 30 degrees. And that is 127.436 Newton. We have our normal force, our weight. Next, we should find is friction. But we don't have any coefficient of friction. The coefficient of friction, incorporating the physics of friction with the geometry of inclined plane, gives us a simple formula for the coefficient of static friction, which is tangent and the angle of elevation. As you can see, tangent of elevation, we have tan 30 and 0.557 coefficient of friction, and input that to our fun equation, or friction is equals to mu n, or normal force. We have 70.821 Newton. Sorry for the stutter. And we have our Wy, weight, friction, normal force. The missing is this Wx and the force applied. So we're gonna find our force applied using this equation. Not literally that equation, but it is easier to use that. So you've seen the answer, but I will explain. This is a force applied. This. And this F of, I just made it up. This is opposing force. Opposed force, or force that oppose the force applied. And this is, the force applied is the forces that oppose this. That's it. And that forces are friction and this Wx sine theta. Why? Because it goes down here. Yeah, it goes down here. That's why we add the two. And we have here the 144.396 Newton. And as you can see here, I made a simple thing. Force applied must be greater to oppose force to have a movement. So we must have a force that is greater than 144.396 Newton. So we input 150 Newton. That is greater than 144. So let's go back to this equation. We have our F net, which is these two. And our M mass is the mass of these three boxes, which is 5 times 3, which we know is 15 kilogram. And our acceleration is missing. That's why we'll divide this to 15 so that we can have an equation of this. This 5.604 is just the subtraction of these two, or the F net. So that's why we have the acceleration of 0.373. Next. So we have our force applied, we have our acceleration. Now we want to find the time to get to the bottom to the top. Let's go to the next slide.
To get the time, we should use kinematic equation. There are three kinematic equations, so we will use the equation that is applicable to us. So we know that we can get the displacement, which is here, and we already have acceleration. So I think this equation is best for us because we already have acceleration and displacement, and we don't have initial velocity. So let's remove that. This isolate the time by dividing 1/2 acceleration, and we have this. And we can remove this square by square root both sides, and we have this final equation, square root of the displacement over 1/2 acceleration. So let's get the displacement. Displacement is or can be calculated using trigonometry, specifically sa katawan. In this situation, we have our adjacent and our angle. So the applicable of us is using cosine, because cosine is equals to adjacent over hypotenuse, and we have our adjacent. So this, we can isolate adjacent by transferring hypotenuse here and dividing it. So we can have hypotenuse equals adjacent over cosine. And input our variables, we have hypotenuse equals 20, which is this. This is supposed to be cosine 30. 30 is the angle, and we have our hypotenuse, which is 23.094. And that now that we have here, we can now put it to our displacement, which is here, and our acceleration, and we have our time, 11.127 seconds. Now we can calculate the energy or the joules that it had. So okay, to do that, we will use the energy of work, which is net work is equals to net force times distance. Distance travel, in our case, that is the displacement. So is the work net is equals to 5.604 Newton, which is this, and times the displacement, and we have our 129.419 Newton per meter. This Newton per meter is simply just joules. Now we have our joules. Let us find how much it costs in the Philippines to run this belt conveyor. We can do that using dimensional analysis. So it is long, but I can explain it to you. This is to know how much of boxes can run in a minute. Then I multiply that to an hour, to a day. Then I multiply the joules, convert it to kilowatts, multiply that kilowatts to the cost per day, and we have our 830 pesos, 0.595. So to know that if paying this a day is worth it, we should, find out how many bucks can this belt conveyor run in this network a day. So this is a dimensional analysis. As first is same here. I found out how many boxes or how many times 11.127 run in 1 minute. Multiply that to an hour, to a day, and multiply on how many bucks I have. Then we got 23,294 bucks a day. So that's a lot. I think for me that is worth it. But if you have more force, then you will have more boxes, less more time. Depends on you. So okay, that's all. I hope that I taught you something today, that you learned something. That is all. Thank you for watching, and thank you. Have a good day.